In their research, Anthony Fontenot and Jacob Rosenzweig collect layer upon layer of information and synthesize them into visually stunning maps. In their Mississippi River Delta study, Reviving the Dynamics of the Landscape, Fontenot and Rosenzweig reveal the unsustainable infrastructural paradigm that has been holding their region's landscape prisoner for well over a century. Among the list of layers that they expose as being tied into this failing paradigm are layers relating to the region's geology, biology, infrastructure, urbanism, economics, and demographics. They begin their study with an analysis of the unique geological history of the delta, particularly that of a unique phenomenon known to geologists as delta lobing.
In geological time, the Mississippi River Delta is still a puppy. The Mississippi River, after collecting millions of gallons of water and millions of gallons of sediment from across the continent, built the Delta Plain as we know it today, all 13,000 square miles of it, one flood at a time, in only 5,000 years. On an average of once every 700 years, the river would jump its track, if you will, and find a new path towards the Gulf of Mexico to unload its muddy contents onto the shallow continental shelf. The 7 different endpoints of the river, or termini as geologists call them, formed 7 different delta lobes.
For Fontenot and Rosenzweig, the most important layer revealed in their geological analysis of the region is the layer, or map, of all the delta's historical distributaries. The 7 termini that form the 7 delta lobes were in fact 7 networks of distributaries. When mapped together onto one page, one can see that these networks spanned across the entire delta.
Every spring, year after year after year, when the lower Mississippi River was swelling up with water, more water than it could carry, these distributary networks would distribute the river's flooding waters across the flat landscape. One flood at a time, the entire delta plain was built this way, until it was able to rise just above sea level. And if you look really closely, you can see that there are several meandering ridges that elevate above the delta plain, sometimes up to 10 feet above sea level. Those are the natural levees left behind by the historical distributaries. Those are the delta's precious high grounds that would later become the favored sites for urban settlement.
This is precisely where the dynamic delta lobing era of geological history was brought to an end, and where the unsustainable infrastructural paradigm that still persists today was born.
As population levels in the Delta region expanded, the annual spring floods were seen as detrimental to everyday life and major economic activities, such as riverborne commerce and agriculture. So layer after layer of infrastructure, first and foremost being the levees, was inserted into the landscape in order to protect the livelihoods of the Delta's citizens.
But, without realizing it, the engineers who designed these infrastructural layers actually put in place the mechanisms that would destroy the Delta's landscape.
Just compare the map of the historical distributaries with the map of today's active distributaries. Whereas countless streams and bayous once reached across the entire delta, now there are only 2. And there are hundreds of miles of wetlands between the 2 of them that are not receiving any of the river's fresh water and sediment, which are essential for them to stay alive.
Well after the 19th and 20th century's proliferation of infrastructure, scientists started noticing that the landscape's natural ecological processes had been compromised by the engineering projects. In particular, they discovered just how crucial of an ingredient flooding had been in the era before the infrastructure was built.
The infrastructures were put in place to channelize the river, to control it, and cut off all the distributary networks that enabled flooding, and the engineers were in fact very successful. Not since the Great Flood of 1927 has the region experienced a single devastating flood.
But the successful elimination of flood threats created unforeseen problems for the health of the landscape. Wetland habitats began disappearing at an alarming rate. In their study, Fontenot and Rosenzweig juxtaposed maps of salinity levels from 1949 and 2001 in order to reveal how much wetland habitat change occurred in those 50 years.
While the habitats of the delta are determined by a number of factors, such as elevation, hydrology, soil type, and microclimate, no factor is more determinant in what a particular area's habitat will be than salinity. So when the salinity levels of delta habitats quickly escalated, the biological pieces of the habitats couldn't adapt in time, and they starved to death, leaving behind expanses of open water where healthy wetlands once flourished.
By mapping the individual layers that are tied into the prevailing unsustainable infrastructural paradigm, Fontenot and Rosenzweig enable both the scientific community and the general public to understand the complex issues that stand in the way of the delta's long-term viability. Furthermore, the maps reveal the interconnections between all of the layers that combine to form the current paradigm. In pursuit of their study, the team recognized the need to map an alternative paradigm in which the lives of delta citizens and their economic activities are protected without jeopardizing the health of the landscape. In their proposal, they seek to revive the dynamics of the landscape, referring back to the floodable historical distributaries and delta lobes, by employing strategies like flexible infrastructure and controlled flooding.
The final 7 slides are excerpted from our larger proposal, in which mechanically controlled bifurcations help to distribute water and sediment to every basin and subbasin of the delta. Urban territories are reconfigured to work side by side with newly designated stewardship areas to allow the landscape of the delta to come back to life again, just like it worked in the era before human settlement, one flood at a time.